60 participants.
पाटील सर सुरू करूया.
इथे
हरकत नाही.
हा ओके सर.
इथे स्क्रीन मध्ये हे करता येईल ना, शेअर करता येईल.
एक मिनिट सुषमा, तुला ऍक्सेस, सुषमा मॅडम तुम्हाला ऍक्सेस देतोय आता.
हो हो, नंतर जेव्हा असेल तेव्हा.
हा ठीक आहे ठीक आहे. ओके, गुड आफ्टरनून एव्हरीवन. एम आय ऑडिबल?
Yes.
तुम्हाला ऍक्सेस दिला.
Yes, you are audible.
Yeah, thank you, sir. Respected Principal Dr. Anil Patil, sir. Today's honorable speaker, Dr. Sushma Ambadekar, madam. All my colleagues in the department and from various colleges, and dear students, I welcome you all for the webinar on periodic introduction to periodic table. And this actually periodic table theme was kept because of 7th February we have celebrated World Periodic Table Day. The seminar was kept on the same day, but due to unfortunate death of Bharat Ratna Lata Mangeshkar, we could not conduct the webinar on that day. Now, because it is postponed to 10th today, we are going to have this seminar on introduction to periodic table. Now, I request our principal, Dr. Anil Patil, sir, to guide us on this topic.
Yeah. Thank you, madam. So, I welcome all of you for this online national webinar on introduction to periodic table. At the outset, I welcome Dr. Sushma Ambadekar, madam, from Department of Chemistry, Dr. Homi Bhabha University, Mumbai, that is Institute of Science. Then I appreciate our Department of Chemistry and Science Association for organizing this webinar on the topic Introduction to Periodic Table. Head of the Department of Chemistry, Professor A.V. Jadhav, convener of this webinar, Dr. Sonali Patil, then my other colleagues who have joined this webinar, my students who have joined this webinar, and other teachers from various colleges. So as Sonali madam has said, on the 7th February, the day is celebrated as periodic table day, and everybody know the importance of periodic table in the study of chemistry as well as understanding the chemistry. And so it is a very relevant topic selected by the Science Association for this webinar. So I thank Dr. Sushma Ambadekar madam for accepting our invitation and being with us today for this webinar. Once again, I welcome her on behalf of all of us, and I request her to deliver her talk. Thank you very much.
Thank you, sir. Now it's my duty to introduce Dr. Sushma madam. Dr. Sushma Ambadekar is from, she is presently working with the Institute of Science, Dr. Homi Bhabha, State University, Mumbai. Her research area is nanoscience, pharmaceutical, wastewater management, solid waste management, chromatographic techniques for method development and validation. कुणाचं तरी माईक चालू आहे, प्लीज ऑफ करा. She has total 48 publication in the care listed journals. Total 7 students completed PhD under her guidance, and there are 4 students MSc by MSc research. We are lucky to have such a versatile person today for the webinar. So now I request Dr. Sushma madam to start her lecture.
Madam, just give me permission to share my screen.
हाँ, just a minute. Chatte sir.
हाँ मॅडम, दिले केले त्यांना को होस्ट.
Okay, Sushma madam, you
शेअर करू शकतात.
Okay, host disable participant screen sharing.
हा, स्क्रीन शेअरिंग. येस,
Screen share.
स्क्रीन शेअर ऑप्शन.
तुम्ही परमिशन द्या ना मला शेअर स्क्रीन करायची.
दिले मॅडम.
नाही येत आहे. होस्ट डिसेबल पार्टिसिपेट स्क्रीन शेअरिंग येते.
पार्टिसिपेंट मला को होस्ट केले तुम्ही.
को होस्ट केलेला आहे.
हा ते हे करा तुम्ही अलाव करा ना मला.
हा झाले का नाही?
नाही को होस्ट काढून टाका ना आणि हे करा ना तुम्ही.
पार्टिसिपेंट
हे करा तुम्ही.
पार्टिसिपंट केलं तर
माझ्या नावावर जाऊन तिथे शेअर स्क्रीन अलाव करा ना. सुषमा मॅडमच्या नावावर जाऊन तुम्ही शेअर स्क्रीन अलाव करा. येस
झालंय.
एक मिनिट व्हिडिओ ऑन. एक मिनिट मॅडम तुम्ही दोन आहेत का?
हो.
एक आहे ना हेच आहे ना स्क्रीन.
पण नाही याच्यातनं वेगळं मी जॉईन झाले याच्यातनं
हा,
वेगळं
मग.
जॉईन झाले.
हॅलो सर.
हा
दुसरा एक मॅडम आहे बघा दुसरा त्याला अलाव करा ना.
कुठल्या मॅडम आहे दुसऱ्या वगैरे?
सुषमा मॅमच आहे.
दोन याच्यात.
दोन आहेत बघा दोन त्या दुसऱ्याला अलाव करा तुम्ही.
2 कडून जॉईन केलंय तिने.
हो. डॉक्टर सुषमा म्हणून असेल बघा दोन आहेत. नाही
डॉक्टर सुषमा म्हणून जॉईन केलंय का?
हो
दोन ठिकाणी join
दोन
झाले.
असणार बघा.
एक लॅपटॉपवर एक मोबाईल
एक लॅपटॉपवर आणि एक मोबाईलवर आहे.
दोन्हीकडे आलाय.
इथं अलाव नाही.
इथं
तेच
डॉक्टर सुषमा दिसतच नाही याच्यामध्ये.
एक मिनिट
पार्टिसिपंट मध्ये दिसत नाहीये सर.
नाही
स्टार्ट व्हिडिओ
पार्टिसिपंट मध्ये
एक
सुषमा अंबर्डेकर दिसत आहेत.
आमचा व्हिडिओ दिसतोय का?
नाही.
नाही
एक इथे लिव्ह होता तर मॅडम परत जॉईन हो ना.
चाटे सर स्क्रीनवर डॉक्टर सुषमा अंबाडेकर दिसत
आता परमिशन द्या.
हं.
आता एक मिनिट नाही तुम्ही होस्ट डिसेबल केलंय. SRA म्हणून आहे बघा. SRA इथं नाव वेगळं होतं मॅडम.
अरे त्याला
SRA म्हणून आहे बघा.
SRA एक मिनिट बघतो.
SRA
तिथला आवाजच जात नाहीये आपला.
नाही जात आहे का? जॉईन हो मॅडम जॉईन हो. SRA म्हणून नाव होतं.
SRA दिसतं ना मॅडम तिथे.
SRA दिसतंय सर चाटे सर.
ऍक्सेप्ट करा. इथून आवाज जात नाही. हॅलो
हा हॅलो
हॅलो.
एक मिनिट
आवाज येतोय?
हा आवाज येतोय.
येतोय.
हा SRA म्हणून बघा ना. SRA म्हणून आहे बघा.
SRA
SRA
आणि
फक्त.
हे पण
आणि मॅडमला ऍक्सेप्ट करा ना. तिथे वेटिंग वर आहे आम्ही. दुसऱ्या मोबाईल मधून आलेत बघा. SRA म्हणून आहे बघा. SRA शॉर्टकट SRA.
चाटे सर SRA स्क्रीनवर दिसतंय.
त्याला allow
हा ते अलाव करा तिथे. SRA म्हणून आहे बघा.
हा SRA ओके.
येस
Screen share.
स्क्रीन शेअरला अलाव करा सर.
Video-
व्हिडिओला नाही, व्हिडिओ अलाव करते. तिथे तुम्ही ना नावावर जाऊन ना लेफ्टला तुमचं दिसेल बघा शेअर स्क्रीन.
Hello, Sonali. Hello.
हा हॅलो मॅडम.
सुषमा बोल.
हा ते ना SRA म्हणून आहे ना तिथे स्क्रीन शेअरला अलाव कर ना.
हो ना, पण ते होस्ट आहेत चॅटेसर. चॅटेसर बघा काय
हो
प्रॉब्लेम.
हो.
एक मिनिट सुषमा.
हो.
मॅडम आता तुम्ही स्क्रीन शेअर करू शकताय.
हा ठीक आहे, झालं. ठीक आहे ना?
इथलीच आहे नाही.
हा तीच डायरेक्ट ओपन आहे.
ओके.
दिसते शेअर स्क्रीन दिसते का?
हो दिसते दिसते.
ओके.
दिसते.
ओके.
ठीक, ओके.
थँक्यू. Okay, thank you, Sonali, my best friend, and Patil
you,
sir,
madam.
HOD, Alibag College. So you are asking me to say something about periodic table. So as a PG professor, we seldom used to talk on periodic table, but as per your request, I am here to say some facts regarding periodic table. Sonali, tell me about audience. They are MSc students or BSc students or mixed audience?
It's a mixed audience. Large number of undergraduate and very small number of postgraduate.
Okay. Okay. So I am considering majority undergraduate. So we will see here what is periodic table. Okay. So name itself indicates periodic means which get repeated. Okay. Something get repeated and that we are putting in table. So what get repeated and in which table we are keeping it. See, this is the outline of your periodic table. All of you are very much familiar with this periodic table. So what is periodic table? Actually, periodic table is made up of rows of elements and columns. Okay. So an element is identified by its chemical symbol. So when we are saying element, it may be metal, it may be non-metal, it may be metalloid. Okay, we will see later on. The number above the symbol is the atomic number. The number below the symbol is rounded, the atomic weight. A row is called as a period and a column is called as a group. We will see. So what happened? In early days, there were number of elements discovered. So what was their objective? Their objective was just to place those elements in a particular table. So what they considered initially, they considered atomic weight as a periodic property. When they are keeping those elements 1, 2, 3, after a certain period, the properties get repeated. That's why they considered that table as a periodic table, because periodically after a certain stage that properties get repeated. Okay, so here is Mendeleev's periodic table. Who was that Mendeleev? In 1969, Russian chemist, and he was teacher, published a table of the elements. Okay, and he arranged, see right hand side, see the arrangement. So this is the initial stage when they are keeping those elements in a tabular form. So what he considered, Mendeleev arranged the elements in the periodic table in order of increasing atomic mass. Atomic mass means initially he considered atomic weight, the number of proton plus neutron. Then after some period, they found out that it is not the atomic weight. It is not collectively the atomic weight, that is number of proton and neutrons, that is responsible for that periodic property. In 1913, Henry Moseley So what he did, he took X-rays and determined the actual nuclear charge, atomic number, actual nuclear charge of the elements, and he arranged the elements in the order of increasing atomic number. Initially, it was increasing atomic weight, and then it became increasing atomic number. There is in the atom of a fundamental quantity which increase by regular steps as we pass from each element to the next. And this quantity can only be the charge on the central positive nucleus. And then they created that periodic law. In the modern periodic table we are using nowadays, elements are arranged in order of increasing atomic number, and the periodic law states when elements are arranged in order of increasing atomic number, there is a periodic repetition of their physical and chemical properties. So this is your periodic law. Now, after keeping those elements in increasing atomic number style, what they found out, the elements can be grouped into three broad classes based on their general properties. Three classes of elements are metals, non-metals, and metalloids. Across a period, the properties of elements become less metallic and more non-metallic. Now see, here is group 1, 2, 3, 4 up to 18. So initially that pink color, those are metals and metalloids. And here blue color, those are non-metals. And we will see clear-cut idea, metal, non-metal, in between metalloids and transition metal. So what are those transition metal? Transition metals are in between transition of the properties from metal to non-metal. So here we will see the properties of metals. Now, my basic question is, when we are saying elements, so audience, so are they present in native form in the nature? Suppose you are saying copper, or you are saying aluminium or gold. So are they present in the form of pure copper or pure gold or pure aluminium? Yes, anybody? Yes, audience? Am I audible?
Please, yes, you are audible. Please
So
answer.
anybody?
Anyone?
No, madam.
No. Okay. Doesn't matter. So
Gold is in native state. Madam, gold
Okay.
is in native state.
yes,
And
gold.
aluminum
What about?
is combined state.
Okay. So when we are saying elements, keep in mind in periodic table we are considering element in their native state. But it is not the case that elements are present in native state in nature. Instead of that, those elements are present in combined state. Now, why those elements are present in combined state? And if those elements are present in combined state, how to get pure element from that combined state? And what are those combined states? So suppose we are considering iron, Fe. Fe is present in oxide form, Fe is present in sulfide form, Fe is present in silicate form. Why? Why this is so? Because those elements are reactive in nature. So why those elements getting reactivity? Because of their electronic configuration. Now here first we will see that elements are divided into three major classes: metals, and then we are having transition metals and gases. So what are those metals? What are the properties of metals? Metals are good conductors of heat and electricity. Metals are shiny, they are ductile, and they are malleable. A chemical property of metal is its reaction with water, which results in corrosion. Okay, those are solid at room temperature. So is there any metal which is liquid at room temperature? Student?
Mercury.
Mercury. Okay. You are reading slide. Good. Who are you? Your name, please. Yes. Now, what we have seen just now, elements are not present in their elemental state in nature. Those elements are present in combined state. So we have seen metals and here are the non-metals. So we will see the properties of non-metals. Non-metals are poor conductors of heat and electricity. Non-metals are not ductile or malleable. What is this ductile and malleable? So we can make long wire or flat surface out of that. So those with the help of these non-metals, we can't make wires or flat surface. With the help of metals, we can. So metals are malleable and ductile, but non-metals are not ductile and malleable. So solid non-metals are brittle and break easily. Okay, they are dull in color. Many non-metals are gases. Now my point is, so metals are combined with non-metals, and after the combination of metal and non-metal, there is compound. Suppose sulfur. Sulfur is non-metal and iron is metal. Okay. So when iron combine with sulfur, that is metal combined with non-metal, so it becomes FeS. What is this FeS? Iron sulfide. So yes, iron sulfide. So this oxygen is non-metal. Okay. So what about oxygen, student? Whether it is metal or non-metal or something else? So here the point is why we are not getting elements present in periodic table in their native state in nature, because metals are reactive and those metals react with non-metals, and we are getting either oxides, sulfides, sulfates, silicates. So why it is not possible to get the elemental state, that particular metal in nature? Any idea? Yes.
Please be interactive.
Yes, those are interactive, of course. That's why they combine with metal, combine with non-metal. But why? Why they are combining? See, universal law. The lowest energy state is stable, right? So each and every system tries to maintain its lowest energy state. Now, when metal you are considering as a system, so when it is present in native form, it is unstable. And when it combined with non-metal, it forms compound and it becomes stable. And what I said, every system tries to maintain its lowest energy level because it gives stability. Okay. Now, why they are getting stability when metal combines with non-metal? Any idea?
Because completion of octet.
Yes. So here this periodicity. So when we are keeping elements in periodic table in that particular format, what happened after a particular period, the properties get repeated, and again we are bringing that next element into first column, right? So here when that metal combined with non-metal, there is electronic configuration, and here their duplet and octet get completed, and that's why that system gets stabilized. And when they are present in that combined form, then how to get element in their native form? Yes, any idea? Yes, student. See, our objective is how to get element in nature. So in nature, elements are present in combined state. Then if we want that element in that elemental state, so metal is element, non-metal is element. metalloids are elements, means a single entity, that is element. And when that entity is combined with others, it becomes compound. You are getting my point?
Yes.
Yes. Okay. So what was my point? When those elements are present in combined state, how to get the element in elemental state? Yes.
Electrolysis.
Just to remove the non-metal. If it is in oxide form, remove the oxygen. If it is in
Heating.
sulfide form, remove the sulfur. If it is in sulfate form, remove the sulfate. If it is in silicate form, remove the silicate. And then we are getting elemental form of that particular metal or non-metal or metalloids. You got it? Got the idea, student?
Yes.
So here we have seen the metal, then we have seen non-metal, and here's the metalloid. So what is metalloid? It is metal-like, and that metalloids have properties of both metals and non-metals. They are solid, that can be shiny or dull. So if solid is shiny, we are saying metal. And if that solid is dull, we are saying non-metal. But the metalloid in between metal and non-metal, they may be shiny or may be dull in nature. So they are having properties both like metals as well as non-metals. They conduct heat and electricity better than non-metals, but not as well as metals. So what we have seen, metals are good conductor of heat and electricity, and non-metals are bad conductor of heat and electricity. But the metalloids, they are having better conductivity than non-metal, but less conductivity than metals. You are getting my point? It is in between, transition. They are also ductile and malleable. That is the property of metals. So silicon is metalloid, metal-like. So silicon is having some properties like metal and some property like non-metal. So up till now, what we have seen, whatever elements are there in periodic table, they are divided into different classes. One of the class, that metal, second non-metal, and third here we are metalloids. So we have seen iron, total metal property, sulfur, total non-metal property, but silicon we are having in between, sometimes metal-like property and sometimes non-metal-like properties. That's the concept of that metalloid. Yes. Yes, student. Yes, am I audible?
Yes.
ma'am. Yes.
Yes, ma'am.
Okay, so let's recapitulate what we have seen up till now. So here the objective is to keep all elements present in nature in tabular form. So that tabular form of keeping elements is periodic table. So why periodic table? Because when we are keeping one element next to another, then the property observed after a certain period, the chemical and physical properties get repeated. And when we are keeping those elements one next to another, after a certain number, again we are bringing it to first column. Now, what are those columns and groups? So what are those groups? Groups are the columns. Those are vertical in nature. You just imagine table. Initially, we have seen that periodic table. So whatever vertical groups are there, those are called as vertical columns are there, those are called as groups. And whatever horizontals are there, those are called as periods. So groups, column of elements are called groups or families. Elements in each group have similar but not identical properties. For example, lithium, sodium, potassium, and other member of group first A are all soft
Soft.
white shiny metals, number of valence electrons. And what are those periods? Each horizontal row of elements is called a period. So you imagine plain table. In table, we are having square boxes. Some boxes are kept vertically and some are horizontally. So one, then down, then at the bottom, these are vertical lines, those are columns. And one next to that, those horizontal lines are periods. So in columns, the properties are similar, but not same, exactly same. So what about those periods? Each horizontal row of element is called a period. The elements in a period are not alike in properties. In fact, the properties change greatly across given row. The first element in a period is always an extremely active solid. The last element in a period is always an inactive gas. So conclusion is, in vertical columns called as groups, the properties are similar, but in period there is drastic change in property from left to right. Those are periods, and group from up to bottom. Those are groups. Is it clear, student? Now, when we are saying the different rows, different columns, the biggest challenge was to keep hydrogen. Whether you are keeping in first column or you are keeping in last column or in between. So hydrogen is typical. So here, if you are asked to get bare proton, only proton, will it be possible to get only proton? Yes, student. When we are considering theory, will it be possible to get only proton? Yes or no?
By
You are
losing
getting my
electron.
point?
Yes, ma'am.
I want only one proton. Will it be possible or not? Only one
Hydrogen
proton.
hydrogen contain
Hydrogen
only
is having
one
only
proton.
one proton and one electron. Okay. So when
Yes.
you are considering hydrogen as it is, there is one electron along with one proton. Yes or no?
Yes.
So what I want, bare proton, only proton.
By losing one electron from hydrogen.
Yes. So what happened? On paper we can write many things. Okay. So when you are writing H plus 1, what it indicate? H plus 1. H
One
plus 1.
electron loss. One electron
Yes.
lost by hydrogen.
Yes. One electron is not there in hydrogen atom. Whole quantum chemistry is based on that bare proton. So when we are having hydrogen as an atom, means we are having entity. In nucleus we are having one proton and one electron is revolving around the nucleus. When we are able to remove that one electron, here is H plus, and that H plus indicate only proton. So here is the concept of isotopes. What is the concept of isotope? Those are having same number of protons but different numbers of
Neutron.
neutron. So 1H1, 1H2, 1H3. What is this? In initially
Isotope.
only one proton. Then you are having one proton plus one neutron, right?
Mhm.
And
Yes.
then you are having one proton plus two neutrons. Now
Yes.
in one, what is the atomic number and atomic weight? Atomic number is the number of proton present in nucleus. Agree with me?
Yes,
And
ma'am.
atomic weight is number of proton plus neutron. So initially 1H1 we are having atomic number 1. Then 1H2 we are having atomic number, yes student, 1
One.
only. Then 1H3 we are having atomic number 1, right? In atomic number concept, we are considering only number of protons, and in all that H1, H, then 1 H2 and 1 H3, number of protons same, 1. And then here we are having number of neutrons different. Then what is the atomic weight of that H1H? 1, 1H2 2, and 1H3 3. Atomic weights are different, 1 2 3, and atomic numbers are same, 1 1 1. Right, student? Yes.
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 Now what we have seen, student, when we are considering the arrangement in periodic table, we are considering atomic number, right? Now this hydrogen is having 3 isotopes with same atomic number. Atomic number is 1. Now all those 3, hydrogen, deuterium and tritium. So where to place all those 3? In one square, or we have to keep in different squares? What is your answer? Consider the placement of isotopes, and the best example is hydrogen. So how we are keeping 1 H1, 1 H2 and 1 H3? This is for your homework. Any answer?
On
Yes,
the basis
student?
of on the basis of atomic number, it should have one position.
One position, right? So when we are considering different elements, those elements are divided into metal, non-metal and metalloid. Up till now we have seen. Okay, gradually we are going towards the higher. So here problem comes when there are isotopes. It is not the case that only hydrogen is having isotopes. Other elements are also having isotopes. So where those isotopes are kept in periodic table. So in periodic table, we are not having so many isotopes. Why? Equal weightage is not given to 1H2 or to 1H3. Why this is so? Because even though isotopes are there, we have to find out the percentage of that isotope present in nature.
Natural
Now
abundance.
fluorine. Yes, someone is having problem. So the most abundant isotope we are considering, and in bromine, what are 2 different isotopes of bromine, and what is the percentage abundance of bromine isotopes? When there are 50-50% abundance of the isotope, then where to keep those isotopes and what we have to consider? Student, you just mention the questions. Whatever I am going to ask you just now, it is not the case at this moment. I won't answer. You just go home. You think over it. As a teacher, my first statement to my student is don't block your thinking. You think on that problem. You find out the objective. Why we are here? We are here to study periodic table. And in periodic table, what we are considering? Placement of elements. And in placement of elements, what we are considering? That atomic number. And in that atomic number, if we are having same atomic number but different atomic weights, where to keep those elements? You got the problem? Yes?
Yes.
Then you think over it. Okay, see hydrogen. The hydrogen square sits top group first A1, but it is not a member of that group. Hydrogen is in a class of its own. It's a gas at room temperature. If it is gas, then it should be at right hand side in periodic table, because we are keeping all gases extreme right. Okay, it has 1 proton and 1 electron in its one and only energy level. Hydrogen only needs 2 electrons to fill up its valence shell. Okay, so here we are saying octet for what I ask you. why elements are
You are not
reactive
audible, Sushma.
in
Hello.
nature. Elements, they are saying that octet here is duplet for that hydrogen. So don't forget this hydrogen. For that hydrogen, what you need? One more, and that you just go, and it is not possible to explain each and everything. I am giving you point to think over it. So you just think over it and then find out the answers. If that hydrogen need one more electron, then what will be the product of that hydrogen? In which form that hydrogen will be there if it want to complete duplet? You think over it. Okay. Now here is your
H2.
H2. Okay. So if it is H2, it becomes molecule, not element. In periodic table, we are keeping elements, right? H plus H, that is H2. Yes or no? Okay. So here is your sodium, that is representation of that particular element. See, on the top, you find 11. What is that element? It is atomic number. And the placement of element is according to their atomic number. And down, what is their average atomic mass? Now, instead of saying only atomic mass, why they are saying average atomic mass? Student, any idea? Yes.
Due to isotopes.
Yes. When isotopes are there, you have to consider isotopes also and the percentage abundance of those isotopes, and then you have to add the atomic masses of the isotopes and divide by the number of isotopes, and here you are arriving at average atomic mass. Is it clear? Yes. Then you are having element symbol. So sodium, Na. Why that Na is called as sodium? Yes. Sodium means there must be SA na, sodium or SO. Why there is Na? Yes. You are getting my point, student? Why that sodium is denoted by Na? That is the basic question. Any idea? Yes. Yes, student, am I audible? You are there now?
Yes, yes.
So, which language is this?
Latin
Sodium.
name. Latin name of
Latin.
sodium is natrium.
Okay. Why Latin language we are using for those elements? Why Latin language? Why not American? Why not Russian? Why not Indian? Why not Chinese? That Latin language is dead language. That language was present once upon a time. Nowadays, no one is using that language. So throughout the globe, we are giving that particular names. Okay. So if I am from India, I need that Sanskrit language, Sanskrit representation for that particular element. But that American, they are not going to accept that. Okay. For that, what is the solution? Use language which is dead. Nowadays, no one using that particular language, and in that language, such names are there, and that's why we are using that language. Latin language, Greek language. No one is using those languages at this moment. So there is symbol, and in that language, that symbol resemble to that particular thing. That's why we are saying that Na for this. Go and find out what is this Na. Why Na? Okay, then is your electronic configuration 281. So in first shell 2, then 8, then 1. The periodic table displays the symbols and names of the elements along with information about the structure of their atoms. Now you just go through that periodic table being a science student, being a chemistry student, it is possible to get periodic table in market. You just go buy it and keep it at your home, and you observe it, try to learn it, and ask different question to your mind and try to get the answers. So here is the representative. How those elements are represented. Now here are different 4 chemical groups of the periodic table. So here is one is your first A, alkali metals. Why those metals are called as alkali? And then is alkaline earth metals. Now anybody knows that alkali means what? Yes. And that alkaline means what? Yes, student. Alkali means what?
Base.
Base. So why it is called as alkali metals? Now you combine lithium with OH, LiOH, then NaOH, then KOH. Okay. So when you are dissolving in water, it gives you bases. Those
Base.
bases are called as alkalis. That's why those metals are alkali metal. And what are those alkaline earth metal? What to do with that earth metal?
Because
Earth
it is
means
found
what?
in earth crust.
Earth crust. So those metals are found in earth crust. What about this hydrogen, lithium, sodium? Where you are getting them? Not in earth crust. Yes. Those are also present in earth crust, na? Yes or
Yes.
no? Then why those are differentiated? Alkali metals and alkaline earth metals. So alkaline means what? Again basic, na? Yes, student.
Yes, madam.
Alkaline means basic, na? Alkali means also basic, and alkaline means also basic. When those second A is called an alkaline earth metals because it gives you alkali bases. Then first A also gives you bases. Then why those are called as earth metals? If those second A are present in earth crust, then what about first A? Are they not there in earth crust, or we are getting in air or in water only? What is your answer? You just note down the questions. What I'm asking. Yes, student, what is your answer? See, what is perfection? Perfection is not a small thing, but small things together gives you perfection. If you want to be a perfect in your knowledge, in your subject, in your chemistry, so you think over those. Okay? Think over those small things. What question I ask you? First A is called as alkali metals, second A is called as alkaline earth metals. Why this is so? Okay. Then you are having 7th A, halogens. Then noble gases, 8A. These are the columns. Alkali metals, alkaline earth metals, halogens, and noble gases. So here are alkali metals. The alkali family is found in the first column of the periodic table. Okay. Sonali madam, my time is over.
You have 10 more minutes.
Okay. So these alkali metals, the alkali family is found in the first column of the periodic table. Atoms of the alkali metals have a single electron in their outermost level. In other words, one valence electron. They are shiny, have the consistency of clay, and are easily cut with the knife. Means they are soft. Now my point is why alkali metals are soft in nature. So one can cut that alkali metals with the help of knife. Why? Yes. Softness of metals. Again, we are coming to your electronic configuration. When single electron is present in valence shell, in outermost shell, then why those elements become soft in nature? Any idea? A student?
Please
Yes,
answer.
alkali metal. Those are yes.
Metallic bond with
Now, student, I don't want your answer at this moment, but you just note down the question. You find out. You just find out different references and get the answers. Okay. So, though superficially we find that periodic table very simple, but when you are thinking about small facts involved, so it is very complicated. So why? So every time you just ask the question why the things are happening, what is the driving force behind that? And when you are asking such question to your mind, so here is analysis. So you are breaking down those things at lowest level, and that lowest level is atomic level.
You are not audible, madam. Hello.
1 minute.
Okay.
Okay, is it okay now?
Yes.
So what I'm asking you, when you want answers, you have to break that particular thing up to atomic level. And what is the dimension of that atom? Yes, dimension of nucleus and dimension of atom. What is your answer? So dimension of nucleus is up to 10 raised to minus 13. What is unit for that? And dimension of your atom is up to 10 raised to minus 9. What is this, meter or centimeter? You just mention those questions. Okay. So dimension of atom is 10 raised to 9 meter. Now 10 raised to 9 meter is called as
Angstrom.
Nanometer.
no, 10 raised to minus
Nanometer.
9. Nanometer.
Nanometer.
Now why that nano size we are considering? Because below that nano size we can't cut that particular element, and when below nano size you are cutting that particular element means what you are doing? You are destroying the basic property of that particular particle. You are getting my point? Why nano? We are having our research at nano level. Why not pico level? Why not femto level? Why we stop at nano level? Because nano dimension is the least dimension we are having for that particular entity. When we are getting nano dimension means we are at atomic level, and below atom we can't cut that particular thing. You got the point, student? So dimension of your atom is nano level. That's why we are getting maximum surface available for reaction at nano dimension level. Okay, there are alkaline earth metals. See the position of alkaline earth metal. They are never found uncombined in nature. Why? The things we are repeating again and again, the elements are present in combined form. And here again they are saying alkaline earth metals are never found in uncombined form in nature. Why? Ask the question. They have two valence electrons. Alkaline earth metals include magnesium and calcium among others. Now why alkaline earth metals are not found in elemental form? They are always found in combined form. Okay. What is the reason, student?
They are reactive.
They are reactive, yes, but why they are reactive? Which factors are involved in their reactivity?
Because of
In
incomplete
periodic
octet.
table, yes, they are losing 2 electrons. And when they are losing 2 electrons, it becomes M2 plus, right? And
Yes.
in that state, they are reactive. And then they combine with these alkaline earth metals combine with non-metals. And there is metal, non-metal combination. And that is compound, right? So which are those non-metals? Just go through it and find out. And those non-metals combine with these metals. And then why those non-metals combine with metals? Metals want to lose electrons. And there is scarcity of 1 or 2 electrons in non-metals. So they
Yes.
come together. So metals give them electrons and non-metal accept the electron and they form compound. And then metal, non-metal system is stable. What I said, universal law. In nature, the least energy state is stable. And this combined form is least energy state. So each and every system tries to maintain its least energy state, right? When energy is more, they are excited. When energy is less, they are stable. Simple. Okay, after this metal, non-metal, metalloids, here are transition metals. Why transition metals are transition? Because there is change from metallic property to non-metallic. And this is the transition. That's why those are transition metals. Now, in periodic table, see the placement of that transition metals. And those transition metals are having color, bright colors. Now, my next question is why transition metals are colored? Why not metals and non-metals? So write down the question. Why the transition metals are colored in nature? They come brightly
Because
colored
of
and are often used to color. Yes. Yes.
because of unpaired electron in d orbital.
Okay. What will happen
DD
if unpaired
transition.
electrons are there?
DD
DD
transition
transition.
in
Okay. If there is transition, if that transition is there, why we are getting color?
by emitting of
Yes.
radiation.
If that transition. Okay. By emitting radiation, why we are getting color? Yes. When you are considering your
Absorption of
eye
visible
as a
light.
detector. Okay. When you are considering your eye as a detector, you can detect colored in visible range. And that
Yes.
range is 400 to 900 nanometer.
800.
So 800. Okay. So when that visible range is there and when that transition, that energy comes under this region visible, you can detect. Okay. So in those transition metals, whatever energy is emitting or that transitions are there. So those transition comes under that visible range. That's why those elements, the transition metals are colored in nature. Okay.
Yes.
Here are the properties of your transition metal. Then representative elements 1A to 7A. What I said, when that element is placed on the top of the column, that is column 1A, 2A up to 7A. So that column having similar properties. Okay. So that first element is called as representative element. So the first element in that first A column, whatever element is placed on top, that is representative element of whole column. You got the concept? Elements are referred to as a representative elements because they are display a wide range of physical and chemical properties. Okay. Now trend in periodic table, electron affinity, electronegativity, These are the properties of that particular element. Now, when we are considering periodic table, we have to consider the transition of those properties from left to right across the period and from top to bottom. Okay, so across the column. So how that ionization energy goes on changing, that atomic radius goes on changing, and that electron affinity and electron negativity goes on changing across the period and across the columns.
Column.
Okay, now here is okay. Now here is your atomic radius. So you consider with respect to you that right hand side and left hand side. So what about your answer? Atomic radius goes on increasing or decreasing from left to right? Yes. Now student, keep in mind one diagram, one picture is equal to 1,000 words. So when there is one representative picture, so no need to explain. It is self-explanatory, isn't it?
Yes.
So what is your observation? That atomic radius goes on changing. Now what I am saying, top to bottom across the column, right, left to right across the period. So first, let me define across the period from left to right, atomic radius goes on increasing or decreasing.
Left to right decreasing.
Of course, from up to bottom, it is increasing.
Hmm.
So again, question comes, why there is decrease in size across the period, why there is increasing size across the column, top to bottom.
Because of nuclear charges.
Now again, see, diagram is equal to 1,000 words. Why I am saying, see this diagram, representative diagram, trends in atomic size. The size generally decreases, that size increases. Then here is Sonali madam, my time is over.
Yes.
Okay, let me complete. So size of ions. Now students, ions are of two types. Cations are anions. What are cations? Positively charged ions. What are anions? Negatively charged ions. So cations means you are removing the electrons and anions means you are adding the electrons. So think about the size of cation and size of anions. Okay. These are the cations, smaller than their parent atoms. Why cations are smaller than their parent atoms? The outermost electron is removed and repulsions are reduced. When that electron is removed, then there is less repulsion. That's why cations are smaller than their parent atoms. Now anions. What are anions? When you are adding electrons. Anions are larger than their parent atoms. Electrons are added and repulsions are increased. That's why anions are larger than their parent element. See size of ions, then metal versus non-metals. Is background. So just go through it. Diagram again. I insist. Just go and get pictorial information. It will be very easy to understand. Then here we are having electron negativity. See electron negativity. That 3D diagram itself indicates. Now when we are considering blackboard and chalk, now we are considering 2 dimension. And when we are having that presentation or PPT, we can consider 3 dimension. And when things are in 3 dimension, it is very easy to understand. Are you agree with me?
Yes.
Now, of course, there are some disadvantages of online teaching, but at a time there are advantages of online teaching because here we can see 3D images, right?
Yes.
Here we can show students the animation, and when 3D images are there animations are there, it is very, very easy to understand that particular concept. Okay, students, we will stop here. Over to you, Sonali madam.
Yes. Thank you,
I
Sushma
tried
madam.
my
for-
level best.
Yeah. I'm sure students must have understood periodic table in detail. Of course, because of time constraint, we could not, I mean, we cannot give extra time. So thank you once again, madam. For all students, there is a link of feedback in chat box. So just fill up that form. And now I request Professor Hake sir to offer vote of thanks. Hake sir. Hake sir.
Am I audible, madam?
Yes, yes.
Okay. Good afternoon to all. It's my pleasure to propose the vote of thanks on behalf of the organizing committee. I would like to thank today's resource person, Dr. Sushma Ambadekar, madam, for such a wonderful and informative session on introduction to periodic table. I would like to thank our principal, Dr. Anil Patil sir, to motivate us and even guide us to organize such a webinar. I would like to thank organizing committee for organize such informative national webinar. Lastly, I would like to thank all the participants for participate in such a national webinar. Thank you again for truly memorable session. We hope you can join us again in future. Have a nice day.
Yes, thank you, sir. I would like to add that we are also thankful to our head of the department, Professor A.V. Jadhav, sir, for encouraging us and giving the support for whatever work we do. Thank you, sir.
Yes, yes, yes.
Thank you, sir. Thank you, madam. Thank you.
Yes. I think we can leave now.